Hello, I'm Ralph Gable of the Electronics for the Inquisitive Experimenter YouTube channel. I've heard it time and time again. I just can't deal with those surface mount devices. And you know, I echoed that same cry of dismay when I was first thrown into the deep end and told to swim. Well, I kept all my fears to myself and I started to learn. In the end, it wasn't nearly as tough as I thought it was going to be. It was more the strangeness of it all than it was the skill factor. Since then, I've probably soldered thousands of surface mount devices by hand and often without the help of fancy equipment. All I had was an illuminated magnifying glass, a decent soldering iron, and a pair of tweezers. I'm here to tell you that you can do this too. And I'm going to show you the basic steps, and the rest is just practice. If you have questions or comments, please feel free to add a comment to this video. If you find this video helpful, please click on the like and don't forget to subscribe. Now, before I get into all the nuts and bolts of it all, I'm going to give you a very, very brief explanation of the why of it all. There are three good reasons for the switch from through-hole components to surface mount components. And the first has to do with printed circuit board design. One of the most precious commodities when designing a circuit board is routing space, which is the space required to run a trace from one place to another on the board. Through-hole devices consume significant routing space through every layer of the PC board. By eliminating the holes needed for through-hole devices, we reclaim a lot of routing space, making it possible to make more compact circuit boards with better signal routing. The second has to do with component size. The very nature of a through-hole device requires more space on the circuit board for the component itself. The body of a 1/4 watt through-hole resistor might only be 0.25 inches or 6.35 millimeters long, but it requires a footprint that is 0.4 inches or 10.2 millimeters between mounting holes in order to accommodate lead bending and the like. The same 1/4 watt resistor in a surface mount device is a mere 0.125 inches or 3.2 millimeters long. Total. With power requirements getting lower and lower, smaller and smaller components can be used. And this allows, once again, to make our circuit boards and thus our devices smaller. The third good reason to go to surface mount devices is cost. Consider a 1K ohm, 1/4 watt, 1% resistor. Now, what is the cost when buying them 5,000 at a time on tape and reel? The through-hole resistor costs 1.2 cents a piece. A comparable surface mount resistor costs 0.378 cents a piece. This is less than 1/3 the cost of a through-hole device. So now let's turn our attention to the tools that you're going to need. There are a few basic tools that you will need to be successful. And this begins with a decent temperature-controlled soldering iron with an appropriately sized tip. Now, depending upon what kind of devices you're soldering, this could mean a fine tip or a hefty tip. So an assortment of interchangeable tips is a good thing. I have three basic sizes that I use. The very fine tip is for the small stuff, the medium tip is for most stuff, and the huge tip is for the heat hogs, which, believe it or not, actually do exist in the surface mount device world. Now, you must be able to carefully control how much solder you're placing on your connections. If your solder is too big, then you will end up adding way too much solder too quickly, and you will have solder bridges or huge balls of solder everywhere. To avoid this, you need some small solder. I use solder that is 0.05 inches in diameter, 60/40 leaded flux core solder when working with most surface mount devices. Next, you will need something to handle the small components with. you will need a good pair of tweezers. Now, I'm not talking about the drugstore variety of tweezers. I'm talking about fine-tip tweezers, something like these. They can be straight or curved, depending upon your preference. I prefer the curve because it allows me to see what I'm doing better. Even with the small solder, you will likely end up with a solder bridge or two in any project, and you will need to remove this. Or maybe you'll be looking to take a surface mount device off of a PC board. In either event, you'll need some solder wick to accomplish these tasks. Now, there are all kinds of solder wick products out there. Be sure the stuff that you buy has a narrow width and fine strands. Here are two possibilities. Sometimes the flux in the solder isn't quite enough to do the job that needs to be done. I recommend buying a Flux Pen, which helps you add some additional flux to make sure the soldering goes fast and that the connection is good. Surface mount devices are generally very small, so you need to see what you're doing. This is where an illuminated magnifying glass comes in. And for years, this is all that I had to use for building boards. Or you could use some sort of microscope. Now, this isn't one of those biology lab microscopes. There's a lot of room between the object lens and the work to allow you room to get in there to be able to do the work. There isn't a lot of magnification either, maybe 4 times. And most of the time, you won't even necessarily need that much. Here you see 2 different types, the camera-based one and the real optical microscope. The demonstration that you'll be seeing in a little bit was recorded using the camera-based microscope. Me, I totally prefer the optical one. Lastly, you will need some way to secure the board from not moving. You don't want to have to be chasing a board around the bench. I have used that painter's blue tape to tape the PCB to the bench. Just be aware that any sort of tape will leave adhesive residue on the PC board. I also have a PCB vise which works very well. I prefer this one over the whole tape thing any day. Now, the next thing I want to talk about is package sizes and types. There are all kinds of surface mount package sizes. Yes, there is a standardized list of sizes and what they mean, but some manufacturers like to have their own aliases too, which makes this whole process a real pain sometimes. For resistors and some capacitors, the nomenclature is quite simple. 0402 size resistor is about 40 thousandths of an inch long and 20 thousandths of an inch wide, approximately. There are metric equivalents to this same nomenclature. For the average hobbyist, the smallest package size that I would use is 0805, and in a pinch, maybe 0603. Then there are the other capacitor sizes and diode sizes, which aren't so easy to fathom. And then the integrated circuits are yet another realm altogether. For the average hobbyist, I would recommend staying with SOIC, SOT23, QFP, or SC70 package sizes, among others. When in doubt, download the data sheet and look at the PCB footprint. The thing to look at is the pin pitch, which is the distance between any 2 adjacent pins. This is often expressed in millimeters. 0.8 millimeters and larger are nice. The 0.5 millimeters are okay, but get pretty tough to avoid solder bridges. And then there are the devices such as BGA packages that don't have any visible pins at all. They exist as pads on the bottom of the chip that you'll never get a soldering iron tip on. Avoid these like the bubonic plague. Now, I've put a link in the description to one of many sites that will give you package size information. In the end, when in doubt, The best thing to do is take a look at the data sheet for the device, look at the suggested PCB footprint to determine if this device is large enough or has a wide enough pitch for you to be able to handle in your shop with your tools. So finally, we get to turn our attention to how to actually solder these things. I need to lay out 4 very important rules before you begin. The first rule, you want your circuit board to be laying flat on a secure surface. Your parts will easily slide off. The second rule, calm winds. Surface mount parts are very light and they will be very easily blown off the board. If you have to sneeze, face away from the board. Third rule, steady, steady, steady. One of the things that I've heard the most about soldering surface mount components is that their hands shake. And as you will see when we get to the demonstration portion, so do mine. Nearly everyone's hands shake. So learn to anchor your hands as close to your work as possible. I rest my wrists on the bench or the PCB vise and maneuver the devices using only my wrists to the tips of my fingers. Find a way that works for you. And the fourth rule is gentle, gentle, gentle. When you pick up your surface mount device with your tweezers, be gentle. It's not heavy. It's not struggling to get away. It is light and it is small. We tend to squeeze hard because we're afraid that we're going to lose it. And when it flicks away, it will be somewhere on the other side of the room, forever lost except to your vacuum cleaner or broom. Once you have it on the PC board, oftentimes you can move it around just by pushing it with your tweezers. Now, with all of that out of the way, let's solder some 2-pin devices. 2-pin devices like resistors and capacitors and diodes and the like are the easiest to put on the board. The first step is to make sure that the pads are clean and flat. If there was a component on the pad before and there's residual solder there, or there is some solder bump of any kind, use your solder wick to clean this off, nice and flat. Next, we want to clean off the pads and make sure it's nice and clean. Now I'm going to apply a little bit of flux using my Flux Pen. The next step is to put a small bead of solder on one of the 2 pads of the PCB. Go out and grab your part and place it on the board, positioning it somewhere close to where it will live. Gently grab the part with your tweezers as the part lays flat on the PCB. Heat up the pad where the solder bead is at, and once the solder bead is molten and flowing, slide the part into place. While holding the part in place, remove the soldering iron and allow the connection to cool before letting go of the part. Once the first side is cool, then solder the other end of the component. I will then often go back to the first end and give it just one more touch of solder to clean it up. And of course, the final step is to clean it all up with a little isopropyl alcohol and a brush. So what about multi-pin devices like ICs and transistors? The good news is that the process for multi-pin devices is in many ways exactly the same. The big difference is the size of the component and the number of things we have to get lined up. Like before, we're looking at to have nice, clean, flat pads all the way around. If there's residual solder on any of them, clean it off with your solder wick. Then I add some flux to the pads using my Flux Pen. I put a little solder on one pad to create a solder bead on that pad. Grab your part and place it on the board, positioning it somewhere close to where it will live. Gently grab the part with your tweezers as the part lays flat on the PCB. Heat up the pad where the solder bead is at, and once the solder bead is molten and flowing, slide the part into place. This time we have to pay attention to all of the pins to be sure that they are centered on their respective pads. The more pins the part has, the more things that we have to look at. While holding the part in place, remove the soldering iron and allow the connection to cool before letting go of the part. Now I will then go to the opposite corner of the part and solder that pin next so as to secure the part on the board. Next, we solder all of the remaining pins. If you get a solder bridge, this is where your solder wick comes to the rescue. Use the solder wick to remove all of the excess solder. Now, you may have to almost completely remove all of the solder from the offending pins to get rid of the bridge. Then you get to go back and re-solder the pins, and this time without the bridge. It is almost impossible to hand solder devices with 0.5 millimeter pitch and smaller without at least one solder bridge, though I have been able to do it. Your solder wick is your friend and worth every penny you pay for it. Lastly, we clean everything up with a little 99% isopropyl alcohol and a brush, and we are done. So what about when you have to get one of these things off of the board? Putting them on is very, very easy compared to getting them off of the board. How do we do this? Well, the first step is removing as much of the solder holding the part in place as possible. Yep, you guessed it. Solder wick to the rescue. So let me show you the process that I use to remove a resistor from a PC board. Using the solder wick, I remove as much solder from the two ends as possible. Then I heat one end of the resistor, lifting gently on the end by rolling the soldering iron tip while pressing it against the end of the resistor. I switch back and forth between the two ends, heating and rolling, and eventually it just will pop off of the board, sometimes leaving a little bit of itself behind. Now we use the solder wick to clean up the pads to get it ready for the new resistor to be soldered in its place. Lastly, we use a little 99% isopropyl alcohol and a brush to clean up everything, and we are done. The next one is a multi-pin device like this 8-pin integrated circuit. It doesn't matter if the chip has 3 pins or 128 pins arranged with 32 pins on each side of the square chip. The process is the same. Let me demonstrate how to remove a multi-pin device using this 8-pin device. First, I remove as much solder as possible using my solder wick. Now I will heat the device pin with my soldering iron and then pull the pin up and off the pad that it was soldered to using a very sharp pointy tool like my electronics probe for my DVM or even a sewing needle. Hold the pin off of the pad and remove the soldering iron heat. When the pin and pad have cooled a bit, then move on to the next pin. We work our way around the part. If your plan is to salvage this chip to be used elsewhere, be especially careful not to lift the pin too much. Gentle, gentle, gentle. We do not want to damage stuff. We also want to be careful not to move the part too much while we're doing this, especially when you get to the last few pins. It is possible to rip pads off of the PCB, and I've done that before. When we are all done, we clean the pads up and get them ready to receive the new chip, and this includes using some 99% isopropyl alcohol and a brush to remove all of the excess flux from the board. The biggest thing in learning how to work with surface mount parts is practice, 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 practice. Go grab some old PC board somewhere that was discarded and take parts off and put parts on until you're comfortable with the process. So that wasn't so bad now, was it? This gives you a quick leg up on working with surface mount parts. Don't let them scare you. If you found this video helpful, please click on the like and don't forget to subscribe to this channel. Thank you so much for watching. Until next time, Toodle-oots.